So looking at the shape, we have a square, and we're looking for the area of the shaded angle triangle in the given question, which is this angle ABE. So first of all, we have to find the given side or an angle in order to be able to find that. So we apply our sine rule to that. First of all, I have this angle at 40, so the remaining will be 90 degrees minus 40 degrees. 90 minus 40 gives 50 degrees. So I have sine E divided by 10 equals what? Sine 50 degrees divided by my 8. So I have this angle here because this is angle 50. So have to cross multiply. So sine E equals 10 sine 50 divided by E. So the value of E is 73.2. So since E is an obtuse angle, and no obtuse angles are angles greater than 90 degrees, I'll have to subtract 180 minus 73.2 degrees. So that gives us 106.7 approximately. Or 106.8 degrees. Okay, so using that angle, marks my obtuse angle here, which is 106.8. Then I can look for my angle ACD. Having that, I'm having 180 minus 73 minus 106, sorry, minus 106.8 and 50 degrees. So when you subtract, what do you have? 180 minus 106.8 minus 50 gives 23.2 degrees. I have 23.2 degrees as my angle at this. So we've gotten that. The question is asking us to calculate the area of the shaded triangle. So if you take a look at the shape here, cutting this, I'll have a right angle triangle. I'll know the length from here to this place. The length from here to this place gives so the total length from this to this is 10. So, but we are going to look for this in order to be able to find the height of triangle ABE. So how do we get that? We apply our formula for finding the area of a triangle, which we have half into what? AB sine C. So if you look at this, we have our hypotenuse of that. No, we don't. So I'm going to use my circular theorem to find the height of this triangle here. I'm looking for the height here. So looking for the height there, I have sine 23.2 which is equal to the height of that divided by 8. So the height is 8 sine 23.2. So 8 sine 23.2 gives 3.15. So I have my height as 3.15. So with this height gotten, I can go ahead to look for the height of angle ABE. So looking for that, just do 10 minus 3.15. That'll give us 6.85. So I have 6.85 centimeters for the height. So now I can use that to find the area of my triangle. So that is half base times height. I have half into 10 times 6.85. So what do we have there? That is 5 multiplied by 6.85 gives 34.25 cm squared. So that is the area of the shaded. The area of the shaded angle here is what we have gotten. So we'll move to the next question. So this is the next question. Calculate the total area of the figures. Below we have two figures there. We have A and we have for B. So we are going to calculate the individual areas of this shape. I have my shape here. We have two triangles, which is A, BD here. Then we also have triangle BEC. So we are going to look for the individual areas of each of the triangles. After then, we add up the sum. But if you look at these triangles, before we apply, we are going to look for the side here and possibly the side here for us to proceed. So I'm going to apply my SOHCAHTOA here using sine 30.6 in order to find this. So I have sine 30.6 equals my opposite, which I termed y, divided by my hypotenuse, which is 8.2. I have y as 8.2 sine 30.6. So 8.2 sine 30.6 should give us that. 8.2 sine 30.6 is 4.17. So my y is 4.17. I've gotten this part as 4.17. So we can use this to solve for the area of both of the triangles, because this can give us the base and this can give us the height of our triangle. Then we look for AD. We'll be looking for our line AD here. So in looking for AD, we still apply our SOHCAHTOA formula to find any of this. So there I can have first 30.6 equals my x divided by 8.2. I'll make here x. So x is equal to 8.2 first 30.6. Gives 7.06. So we have our x as 7.06. After getting x as 7.06, we can proceed to look for the area of the individual triangles, area of ABD and area of BCD. So I'll start with area of triangle ABD. So ABD gives what? Normally we know that area of the triangle is half into B times H. But this is half of the triangle. So I'm going to remove the half. I'll just do base of it multiplied by the height. So our base is 7.06 times 4.17. That gives 29.44 cm squared. That is area of triangle ABD. And area of triangle BCD gives, we are using half into AB sine theta. So that is half of it multiplied by 4.17 multiplied by 10.4 sine 100. That gives us 21.35 cm squared. So having gotten this, I bring both of them together. Area of that ABD 22.44 plus 21.35 is 50.8 cm squared. So that is the area of the triangle in A. So continue with this. This is quite easier than the first one. We have our line AD, and also for the bigger triangle is AC. So we have two triangles joined together to make a larger triangle. So the first thing I want to look for my angle marks here. Then after then, I look for the side here. So it's easier for me to find the entire area of the shape. So looking for the angle here, we apply our sine rule, which we have 4.8 divided by sine 75 equals to this angle marker D here. I'm taking that angle as 3.9 divided by sine D. So cross multiply to find D. We have sine D as 3.9 sine 75 divided by 4.8. D is sine inverse of 0.7848. So the angle at B is 51.7, approximately 52 degrees. So I have this angle here as 52 degrees. Having gotten this angle, we can find the third angle here. I will note that the sum of angles in a triangle is 180. So finding the angle at that point, I have my 180 minus 52 plus 75. So 180 minus 52 plus 75 gives 53 degrees. So I have angle 53 degrees at that point. So this angle is 53 degrees. Having gotten this angle at 53, I can use that to solve for or make this X or B. I think B is better option for that. So let's have that as B. So we have B over sine 53 equals any of the sides you want to use, 4.8 over sine 75. So our B becomes 4.8 cross multiply. So we have 4.8 sine 53 divided by sine 75. B equals your calculator 4.8 sine 63 divide sine 75. 3.96, which is 4 cm. So my B is 4 cm. So if you take a look at the triangle, I'm going to add up the entire length AC. So I have 4 plus 24 gives 20. Sorry, 4.24, not 24. So 4.24, that is, we are having that as 2.4. Okay, so that is 4 plus 2.4. That's what we are having there. So 4 plus 2.4, not 24. So 4 plus 2.4 gives 6.4 cm. Have you gotten that? We can look for the area of the triangle. So we are having half into AB sine C. That is half into 6.4 multiply 3.9. I'll take my sine of angle sine 75 degrees, which gives us 12.05 cm squared. So the area of our triangle is 12.05 cm squared. So we are moving further. So the next question here says in triangle ABC, AB is 10 cm, BC is A with 3 cm, AC is 5 with 13 cm, and angle ABC is 150 degrees. Calculate the value of A and the exact area of triangle ABC. So we have two questions. First, I want to draw a sketch of my triangle ABC. Okay, so I have my A, B, C. And side A, B is 10 cm. Side BC is A root 3 cm. Then we have angle A, BC at 150 degrees. Okay, then we have our AC as 5 root 13 cm, 150 degrees here, root 13 cm. So the question is asking us to find the value of A here. So we are looking for that value of A. So looking at this, we have three sides given, side here, side, and an angle given. What formula comes, trigonometry formula comes to your mind? We'll be applying our cosine rule. Remember our cosine rule that says A squared equals B squared plus C squared minus 2BC cos A. So we have our A, which is what? A, we have our A, we have our B, we have our C, and we have our cos of angles. So if you look at the one we have here, we have the B, we have the two sides B here. I'm going to use that, that is 5 root 13 squared equals 10 squared plus A root 3 squared minus 2 multiply 10 multiply A root 3 cos 150 degrees. 5 root 13 square will give us, you can do that on your calculator, that is 25 multiply 13, which is 10 square is 100 plus A root 3 square will give me 3a squared minus 2 times 10 times a root 3 gives 20 a root 3, then plus 50 plus 150, plus 150 is giving me minus root 3 over 2. So I multiply by minus root 3 over 2. So this is what we have. Then multiplying 25 by 13, we have 325 minus 100 equals 3a squared minus this cancels out to give me 10. So I have 10a root 3 times my root 3 there, which is giving us minus 10 root 9 minus 10 root 9. Don't forget your a. Let me put my a here. When I'm done, I'm going to include my a. So minus 10 root 9 will give us minus 10 times root 9 is minus 10 times 3. Minus 10 times 2 will give us minus 30a. So we have minus 30a there. I have 325 minus 100. 325 minus 100 gives us 225 equals 3a squared minus 30a. So 225 equals 3a squared plus minus is plus 30a. So I'm going to rearrange the formula to have my quadratic equation. I have 3a squared plus 30a, move 225 over, it becomes minus 225 equals 0. Here we can apply the quadratic formula of minus b plus minus b squared. I have b squared minus 4ac divided by 2a. So our b is 30, our a is 3, b is 30, and c is minus 225. So applying this formula, I have minus 30 plus minus 30 squared minus 4 multiply 3 multiply minus 225 divided by 2 multiply 3. So we have minus 30 plus minus 3,600 divided by 6. That gives minus 30 plus minus 60 divided by 6. So minus 13 plus 60 divided by 6 gives us 30 by 6. So my value for that is equals to 6. So I have my A as 6. So we've gotten the answer for the value of A. So A given to us here is 6. So now we're looking for the exact area of triangle ABC. So the area of my triangle will be half AB sine theta or sine C. So that is half into our AB. Our A is 5 and 3. And our B is 10 sine 150 degrees. So we have 1 over 2 multiplied by 5 root 3 multiplied by 10 sine 50 gives 1 over 2. We have 5 root 3 times 10, which will give us 50 root 3 divided by 4. That's 2 times 2 is 4 then. So divide, I have 2, I have 25. So the area of that triangle is 25 root 3 divided by 2 cm We have 3 points, A, B, and C. We coordinate A as 0 and 1, and coordinate B as 3 and 4, and coordinate C as 1 and 3. So they are joined together to form a triangle. The question is, we should fill that first. ACBA is minus 4 and 5, and calculate the area of triangle ABC for the 3 given points. So I'm going to sketch my triangle ABC. Okay, so I have the points given to me. So they say A is 0 and 1, and B is 3 and 4. So C is 1 and 3. Then if you look at this, you're looking for AB, that's the distance AB, and also distance BC, and distance AC. So we apply our distance formula. Our distance formula says y2 minus y1 squared plus x2 minus x1 squared, all into your roots. So for A, B, looking for distance A, B, I have, this is y, this is x1, and this is y1 for A. This is for our B, we have x and y. Also for our C, this is x and y. So using my distance formula for line AB, I have 3 minus 1 squared plus for our AB, I have 3 minus 0 squared, because that is x minus x, and 4 minus 1 squared into your roots. So I have 3 squared, 3 minus 0 is 3, so I have 3 squared plus 4 minus 1 is also 3, that's 3 squared. So that gives 9 plus 9. So my AB is root 9 plus 9. So root 9 plus 9 gives what? Root 18. So gotten the distance between A and B as root 18 cm. Same formula will apply to find our BC. So looking for BC, same thing. I have y2 minus y1, that is 3 minus 4 squared plus 1 minus 3 squared in roots. So BC gives 3 minus 4 is minus 1 squared plus 1 minus 3 is minus 2 squared in your roots. We have BC as 1 squared plus 2 squared. BC equals 1 plus 4. By BC, we give root of 5. So for the triangle, I have my BC as 5 cm, or 5, since we are not working with any given dimension. Then I'm going to look for the last one, which is AC. So using the same formula of y2 minus y1. So for our AC, we have 3 minus 1 squared plus 1 minus 0 squared into my roots. So AC is equal to 2 squared plus 1 squared. AC is 4 plus 1. So my AC is root 5. So we can see AC and BC are gotten that, we'll go back to the aspect of the question that says we should show that cos ACB is equal to minus 4/5. I'll bring my triangle here. So we have our triangle ABC, ABC, where we have AC as root 5, BC as root 5, and AB as root 18. So having gotten this, we are going to prove that cos ACB is equal to minus 4/5. So applying the formula we can apply is the cosine formula. So we apply cosine formula, looking for cos of angle ACB. So looking for that, I'm going to have that as my cos. Cos C, if you remember, if you have cos C, if you're looking for the cos of angle, cos C will give us A squared plus B squared minus C squared divided by 2AB. So looking for that, I have cos C as root 5 squared plus root 5 squared minus root 18 squared divided by 2 multiply root 5 multiply root 5. We have cos C as root 5 squared is 5 plus 5 minus 18 divided by 2 times 5. That's root 5 multiplied by root 5 gives root 25. So square root of 25 is 5. We have 5 plus 5. 10 minus 18 is minus 8/10. So 2 can go 4, 2 can go 5. Therefore, we can say our cos C is minus 4/5. We have proven the fact that asks us to show that cos of angle ACB is minus 4/5. Then we'll move to the next question, which is calculating the area of triangle ABC. So we are having half ABC sine C. Our A is root 5 and our B is root 5 sine C. So the sine C will be our cos inverse of minus 4/5 together angle. And that will give us 143 degrees approximately. So we have our sine C as 143. I have 1/2. 5 multiplied by root 5 is root 25. Square root of root 25 is 5. Multiplied by sine 143. So we have 1/2 times 5 sine 143. Multiplied by 5. 5 sine 143 gives 3 divided by 2. We have our answer as 1/2 centimeters squared. So that is the area for triangle ABC. A parketer walks 1.2 kilometers due north from his hut at point A to point B. They're telling us this is the location of the hut to point B. He then walks 1.4 kilometers from point B to point C on a bearing of 110 degrees from that. First question says find how far he is from his spot when at point C. Give your answer in kilometers to pre-significant figure. So the first thing we have to do here is to find the remaining angle for this, which you know is 180 degrees minus 110. This gives 70 degrees. So we have two sides given to us, 1.2 and 1.4, and we have an angle given to us. So we can simply find my length of AC. So looking for AC, I'm applying my cosine rule to that, which I have as A squared equals B squared plus C squared minus 2BC cos A. So I have that line, I'll make it x squared is equals 1.2 squared plus 1.4 squared minus 2 into 1.2 multiply 1.4 cos 70 degrees. That's we give x squared 1.2 plus 1.4 gives 3.4 minus this, because this gives 1.15. X squared is equal to 2.25. Since we are looking for x, our x becomes root 2.25, which gives x as 1.5 kilometers. So we've gotten our line AC as 1.5 kilometers. So he said that's half. He said we should find how far it was from his source when at point C. Give your answer in kilometers. Then having gotten that, we move to the next part of the question. Says work out the bearing of the heart from point C. Give your answer to the nearest degree. So we are going to work out the bearing from where point C, this is our point C, we are going to work out the bearing of his heart. So taking that point, I want to get the triangle so we can work effectively with it. So this is the bearing of the heart from C. I'll draw my cardinal point at that point here, you can see. So I'm looking for the angles here. We know that the angles from this point to this point is what we are looking for. Okay? So bear in mind, you are looking for that angle there from here to here. So I'm looking for that theta. We already know that from here to this point is 180 degrees. So when you look for the other value here, add to 180 will give you the bearing from C. We have 70 here. Watch out for this angle here. This is an alternate angle. When you go out for your bearing, look for your alternating angles. So this place becomes 70 degrees. And the angle at this point is 90 degrees. So I have 90 minus 70 gives 20 degrees. The angle at this point is 20 degrees. So what is our angle here? That is what we are looking for. We'll look for this angle here, then we can proceed with this angle here. So applying our sine rule to this, and we have 1.2 divided by sine C is equals 1.5 divided by sine 70. So sine C is cross multiply 1.2 sine 70 divided by 1.5. 0.5. So my C of angles will be sine inverse of 0.7518. C gives 49 degrees. So simply we are saying the angle at this point here is 49 degrees. So if the total angle at that point is 49, then you look for this angle here. That will be, how do we get that angle at that point there? If from here to here is 49. Simply that means 49 minus 20. So we have 49 minus 20 degrees will give us 29 degrees. So the angle at this point here is 29 degrees. But taking a look at it again here is 90 degrees. So in order to get this angle marked here, I have to do 90 minus 29 degrees. That gives 61 degrees. So we've gotten this angle here as 61 degrees. So therefore the total bearing is going to be 180 plus 61 degrees. That gives 241 degrees. So that's the bearing of the hot front point C. Next, we are asked to find the area enclosed by his work. So how far or what is the area of the total distance he has walked? So we are going to use our area formula, which is half into AB sine C. That is half into 1.2 into 1.4 sine 70 degrees. So that gives 0.789 kilometers. So that is the distance K, the area enclosed by the triangle. Let's move on to the next question. Says a windmill has 4 identical triangular sails made from wood. If each triangle has sides of length 12 meters, 15 meters, and 20 meters, what are the total area of the work needed? So let's get a sketch of our triangle, because the windmill is the triangular shape. Triangular sails. So I will have 12, 15, and 20. We are looking for the area of this. So I'm going to look for my cos of angle. I prefer to look for this angle at this point here. So using our cosine formula, we have cos theta is equal to 12 squared plus 15 squared minus 20 squared divided by 2 times 12 times 15. So our cos theta is equal to 144 plus 225 minus 400 divided by 360. Cos theta is equal to minus 31 divided by 360. Cos theta is equal to minus 0.086. Our theta becomes cos inverse of minus 0.086. So the cos inverse of minus 0.086 gives 94.9, which is approximately 95 degrees. So we've gotten our theta at that point at 95 degrees. Then looking for the area of the triangle, we have half AB sine theta or sine C. So we have half into 15 multiply 12 sine 95. So what do you have half into 15 multiply 12 sine 95 degrees gives 89.60 or 89.7. So I have 89.7. If you go back to the question, it's saying it has 4 identical triangular shapes. So because of the 4 identical triangular shapes, I will multiply my answer by 4. This gives 358.6. 358.6, which is approximately 359 meters squared. That is the total area of the windmill. It has 359 meters squared. Moving forward, we have the perimeter of triangle ABC, which is equal to 15 cm. Given that AB is 7 cm and the BAC is 60 degrees, we have to find the length of AC and BC and also the area of the triangle. So get a sketch of your triangle. We have A, B, and C. AB is 7 cm and the BAC is 60 degrees. Then we have ABC, the perimeter of it, and we know perimeter is all the sides of your triangle added. So I'll make here X, I'll make here Y. So simply they are telling us 7 plus X plus Y is equals to 15 cm. So that means X plus Y is equals to 15 minus 7. My X plus Y gives 8. So making X subject to formula, I have X as 8 minus Y. So I have my X here as 8 minus Y. In the place of X, you put 8 minus Y. And going back to this, I'm going to apply my cosine rule in order to find the value of X. Applying the cosine rule to that, we already have our side here, we have this side here, and we have this side here. So I'm going to have y squared is equals to what? 7 squared plus 8 minus y squared minus 2 multiply 7 multiply 8 minus y cos 16. So we have y squared as 49 plus expanding 8 minus y. We have 64 minus 8y minus 8y plus y squared. Then we have minus 2 times 7. That is minus 14 multiplied that. Or you have minus 2 into 56 minus 7y cos 60. So cos 60 is 1 by 2. I have 49 plus 64 minus 8 minus 8 is minus 16y plus y squared. So this 2 here cancels out. Opening the bracket, I have minus 56 plus 7y. So that is for the value of our y squared. What do we have here? We have 67 49 plus 64 minus 56 gives 57. Minus 16y plus that gives what? 9y. Plus our y square. So moving your y square over makes y squared 0. So we have 0 equals 57 plus, minus 9y. This value is negative 9y. So moving our 9y to this, we have positive 9y equals to what? 57. So our y value is 57 divided by 9, which gives what? 6, 1 over 3 cm. So if we've gotten y as 9 over 3, I would say y is 8 minus that. So that means our x value will be 8 minus 6, 1 over 3 cm. That is 8 minus that will give us, if you are using your calculator, 8 minus that should give you one whole number. 2 over 3 cm. So we've gotten the value for the total side. So we have 1 whole number 2 over 3 and 6 whole number 1 over 3 for your values. Or you can make, going back to what I did earlier, you can also make y the subject to the formula here by making y is equals to 8 minus x. So I could also put the values of 8 minus x here and leave here as x. It will still give me the same answer I got. So going back, I have the area of the triangle, which is half AB sine C. I have half into 7 multiply 1 whole number 2 over 3 sine 60. So when you have that, we have 5.05 centimeters squared. So that is the area of the shape. In the triangle ABC, AB is 40 centimeters, BC is 12 centimeters, and CA is 15 centimeters. We are asked to find the side of angle C, giving your answer to 3 significant figure, and also find the area of triangle ABC, giving your answer in centimeters squared to 3 significant figure. So whenever you're given a question, first approach is to sketch the given triangle. It's not, you are not drawn to scale. So I have my A, you can fix it. Our AB is 14 centimeters. Our BC is 12 cm. And CA is 15 cm. So we are asked to find angle theta, which is the angle at C. So this is easy using your cosine formula, where we have our cos equals what? A squared plus B squared minus 2 minus C squared, minus C squared divided by 2AB. So we have cos angle of C is 12 squared plus 15 squared minus 14 squared divided by 2 times 12 times 15. So our cos C is 144 plus 225 minus 196 divided by 360. So cos C, to add up, what do we have? 144 plus 225 minus 96. 144 plus 225 minus 196 gives 173. So we have 173 divided by 360. So cos C is 173 by 360. 173 divided by 360 gives 0.4806. So I have cos C as 0.4806. So C is cos inverse of 0.4806. So our C angle is 61.3 degrees. So we've gotten the angle at C. Then we'll move ahead to finding the area of the triangle. So finding the area of the triangle, we have half into AB times C. We have half into 12 times 15 times 61.3. That gives 78.9 centimeters squared. So we are done with this question. So let's move ahead to the next question. A flower bed is in the shape of a quadrilateral as shown in this diagram. We are to find the sizes of angle DAB. We are looking for angle DAB and also angle BCD. And after then, we find the total area of the flower bed and the length of the diagonal AC. So the first we'll be looking at finding the size of angle DAB. So if you look at this, we have 3 sides given to us. And we are looking for our angle marked here. Going to our cosine rule, I have cos A is equals to what? B squared plus C squared minus A squared over 2BC. So our cos A will be 2.1 squared plus 4.2 squared minus 5.9 squared divided by 2 into 2.1 multiplied by 4.2. So our cos A is minus 12.76 divided by 17.64. Our A will be the cos inverse of 0.7233, which gives 43.67. Taking a look at angle at A, we know it's an opposite angle. That angle is greater than 90 degrees. So how do we get the value for A? So like we done earlier, that is 180 minus 43.67, which gives us 136.3 degrees. So my angle at this point is 136.3 degrees. So we've gotten the angle at A, then we are looking for the second angle, which is the angle at C using same cosine formula. We have our cos C is equal to 7.5 squared plus 3.5 squared minus 5.9 squared divided by 2 times 7.5 multiplied 3.5. So our cos C will give 33.69 divided by 52.5. C becomes the cos inverse of 0.6417, which is 50 degrees. So we've gotten our angle at this point at 50.1 degrees. So the next part of the question is finding the total area of the flower bed before we go to the diagonal. So looking for the area, I'm having half A, B, sine C. So I have half into 2.1 times 4.2 sine 136.3. So that is for the first triangle because we have two triangles, that is 3.05. Then to the next triangle, I have half into 3.5 multiply 7.5 sine 50.1. And that should give us 10.1. So adding both of the areas, I have 3.05 plus 10.1 is 13.1 meters squared. So we've gotten the area of the shape. So we've got the area of the triangle. Then next we're looking for the diagonal, which is the length of AC. So looking for the length of that diagonal, what do we apply? If you look at that triangle, we have to find this angle at this point and this angle at this point. So if we get both angles added together, we can have the opposite to our diagonal. So we are going to look for these two angles. So this is the diagonal we're looking for. Then I'm looking for this angle. Let me say theta 1 and theta 2. So both angles will give me the entire angle at my diagonal. So I'm using the sine rule here. I have 5.9 over sine 50.1 we give 3.5 divided by sine theta. That is for this angle. Here is what I'm using. Okay? Because here we got here as 50.1. So looking for my theta, I have 3.5 sine 50.1 equals 5.9 sine theta. Divide both sides by 5.9. So we have our theta as sine inverse of 0.2459. So our angle that is 14.2 degrees. So getting our second theta as 14.2 degrees. Then we proceed sorry, I think we have it as 27.2 degrees, not 14.2. 27 sine inverse, sorry, keep sine inverse of 0.2459 gives 459 14.2. Oh, sorry, I just noticed a slight correction here. I think this gives 0.4551. Yeah. So shift sine inverse of 0.4551 0.51. (27.1 degrees). So my theta at that point is 27.1 degrees. So I have here as 27.1 degrees. Sorry, that was a slight mistake from my part. And looking for the other angle here, I have, using the same sine rule, we have 5.9 over sine 136.3. We give 2.1 over sine theta. So cross multiply. I have 5.9 sine theta equals 2.1 sine 136.3. Divide both sides by 5.9. Divide both sides by 5.9. So sine theta is equal to 0.2459. So my theta becomes a sine inverse of 0.2459. That gives theta as 14.2 degrees. So gotten this is 14.2. So adding up, this will give me the entire angle for angle facing that. So I have 14.2 plus my previous angle, which is 27.1 degrees. That gives 41.3 degrees. So now I can apply my cosine rule to find my length of diagonal. So I have c squared is equal to 7.5 squared plus 4.2 squared minus 2 multiply 7.5 multiply 4.2 cos 41.3. So that gives us 3.89 minus 47.33. So my c squared is equals 26.56. We have our c as root of 26.56. So our c is 5.15 meters. So therefore the length of the diagonal AC is equal to 5.15 meters. Thank you for joining us for today's class. This is how far we can go for solving area of triangles using our sine and cosine rule. So if you have further questions, you can try on your own, applying all the formula and all the trigonometry rules we have used. Thank you. Hope to see you in our next class. Please keep liking our videos. Thank you.